Hello learners, in this particular session we will study about different data structures that are being employed in R programming languages. Mostly in programming languages that you have seen data structures, but here in R programming there are different data structures that you will find in C or C++. Like you have seen stack, queue and any other type of data structure previously. So in R programming the data structure part is a little bit different than you will find in any other traditional programming language. So starting with the data structure, the most commonly used data structures that are being employed in R are, the frequently used ones are vectors, lists, matrices, arrays, factors, data frames. So you may have already seen the data structures like array, and with the help of array we can make matrices. But these are two different data structure in the R programming language. And list is also a very familiar data structure that you may have seen in Python language. In the similar way here the list data structure is also present in R programming language. So data frames are very similar to a table format, and factors and vectors are very efficient data structure that we will discuss in this particular session. So starting with the first data structure, that are vectors. So do not mistake these vectors like scalar and vector quantities. So these vectors have a different meaning in computer science. So vectors are actually, when creating a vector with several items, you should use the method which combines the elements into a vector. So what happens is that C method we have to use it to combine different classes like integer or any other data type. You can use the C stands for combine method. So you can use C method and then write anything in between the brackets of C to combine it into the vector format. So vector, if you see the example here, so simply the example is very simple. So we are simply using the variable name orange, and we are using the C method that you have already seen. The C method is for combine, and we are taking red, green and yellow. So we are saying that these are the different colors that are being assigned to a variable name orange. And when you print orange, so it will directly tell you about the red, green and yellow class. And when you print the class of orange, it will show you, because it's a character variable. If you clearly look into the example, you will see that red and green have only one apostrophe, one colon, one comma, and the yellow class have two quotation marks, and the red and green have only one quotation mark. So what it means is that, so there is no error in between. So I have already told you that you can use one or two quotation marks. It's one and the same thing. So when you combine it with the help of a method named C, so C stands for combine. So you are combining these three different colors, and you are putting these three colors together and entering that colors into the, assigning the values of this to the variable orange. And when you print it, it will simply say red, green and yellow. And when you print the class of orange, now the class is different, because we are storing only the character values there. So it will say that it's a character. So the class of this is character, and this is referred to as a simple vectors. So the vectors are very simple data structures that are being most frequently employed in R programming. Similarly, we have another data structure, that is list. So lists are very frequently used in other programming languages like Python. So this is a widely used data structure. So it is very similar to what we use in Python. So if you see here, it is again a special kind of a R object that can simply store data items. including vectors, function, and even other list. So the main advantage of this is that you can use different data types inside one list, and you can use a list within a list also. So that is one of the biggest advantage of using diff list as a data structure in R. So if you see the example here, so it's very simple. It says list A has been assigned a value with a variable name list. Repeat. So list A have been assigned a value of 253, 21.3 and a mathematical function sine. So these are three different values and they are combined with the help of a C functions. So firstly we have used C function to combine these three separate data types. If you see, 253 is an integer and 21.3 is a different data type, sine is again a different data type, and you can use the C function to combine these three separate data structure into one, and you can put these three separate data structures into a list. And when you press and when you write print list A, it will one by one print the contents of the list. So first content is 2, 3 and 5. So first it will list out 2, 3 and 5, and then in the second index it will store a value of 21.3. So it will print 21.3, and in the third index it will say that sine is a function, so it's a primitive function, so it will say function x dot primitive in quotes sine. So because these are three different types of data types, so when you print the whole list, it will print in a way that is being shown to the in your screen. So if you look at it, also if what will you do if you want to print a specific item in the list? So instead of writing print list A, so you can simply write list A and then you can start a square bracket, and after the square bracket you can write the index. Okay, so what do I mean by this is that if you write print list A square bracket 1, so it will print 235, only 235. And if you write list A, print list A in the square bracket, if you write 2, it will only print 21.3. Similarly, if you write print list A square brackets 3, so it will only print function x dot primitive quotes sine. So this is how the list data structure will behave. So you have to keep this in mind that if you want to print a specific index, the bracket have to be square brackets. That is being shown in the screen also. The square inside it we can write any index. So if you write round brackets, it will throw an error because it will not recognize that what are you trying to print. So this is how you can print any item in the list. Similarly, moving ahead is also a very popular data structure, that is matrix. So matrix is again a combination of row and column. So the only here you can maximum write a matrix of 2 dimensions, 2-dimension matrix that can be written in R programming. So the format is very simple. So what you have to do is that you have to take m equal to matrix. So this is the keyword that you have to use, and simply use the C functions. Repeat. So firstly you have to take the matrix and you have to assign a value of that matrix to m. So what we are doing is that taking a variable m and then writing the keyword matrix, and whatever you want to write in the matrix you have to take it with the help of a C function. You already know that. So C function is used to combine all the contents that you want to write in the matrix itself. So in the next in the next one you have to decide what will be the parameter. So what do you want the number of rows and how many number of columns you want. So you have entered 6 elements here. So 1, 2, 3, 4, 5, 6. So either it can be one row, 6 items. So that is also fine. 1 by 6 or 6 by 1. 6 by 1, 6 rows, 1 item. So that can also happen. Another way is that the number of rows can be 2 and the number of columns can be 3, or another way can be that the number of columns can be the number of rows can be 3 and the number of columns can be 2. So if you multiply it, it will again constitute to a 6 value. So the total number of items are 6. That is why we want total elements in a matrix as 6. So it is up to you that which dimension matrix do you want, and in that context you can set the number of rows and number of columns. So the last parameter is that by row. So it is set as a true and you are simply printing the values of m. So if you see here what is happening, by row means that you want to enter the values by the row. So what it means is that firstly you will enter 1, 2, 3 in one row and 4, 5, 6 in second row. Okay. So what if I do by row equal to false? So what will happen here? It will enter the value column wise. Okay. So what will happen in the first column? It will enter 1, 2. In the second column it will enter 3, 4. In the third column it will enter 5, 6. So that is the usage of the keyword by row. Okay. So in this particular example, the by row is set to true. So that is why the values are entered row by row. So the first row it contains 1, 2, 3, and in the second row it contains 4, 5, 6. So it is dependent upon the user, how the user wants the input to be. Okay. So moving on forward, another example is arrays. Another example of a data structures is arrays. So there can be multi-dimensional arrays, there can be one-dimensional arrays, there can be two-dimensional arrays. So if there is one like in the previous slide we have already seen a two-dimensional matrix. So matrix and arrays are very close to each other. So if there is one-dimensional array, you can write in the form of matrix as well. So it is also fine. But you can also write one-dimensional array or two-dimensional array. But if you want to go beyond that, so in matrix you cannot write a 3 by 3 matrix, or what you say, 3-dimensional matrix. So arrays can be in the number of desired dimension the user wants. It can be in that way. So it can be 3-dimension, 4-dimension, whatever the user wants. So that is the applicability of arrays. That is why it is widely used in R programming. So arrays in R programming can have any number of dimension, while matrices only can have 2. So the maximum it can have 2. To generate the desired number of dimensions, the array function accept a dim property. So dim property is referred to as the dimension property. So in the code snippet that I'll show you the example, we populate an array with 2 matrices of size 3 by 3. So in the example, if you see the example here, so we've taken a variable d. Again the keyword here is array. Now we are taking 2 particular colors, that are red and green, and we are telling the dimensions here with the keyword dim. So dim, and we are giving again C function we are using, it is given as 3, 3, 2. So what is happening here is that we want two arrays of 3 by 3 matrix, and red and green color can be used, meaning the input to that particular arrays can be red and green. So it is dependent, you can put any value here. So it can It can be multiple values, red, green, yellow. You can put any number of colors. You can put 9 colors here. This is also fine, but you can only give 2 colors. It will adjust automatically. So that is the beauty of using R programming. So when you print the array D, so what will happen here, you can see that it is printing 2 matrices that are 3 by 3. So check here in the first matrices, if you see the colors are ranging, because it is by default it is by row set to true. So it is printing red, green, red, green, red, green, red, green, red. Okay. So if you check from by row, because by row is always set to true, so it is again printing the color as red, green, red, green. So it is like alternating the colors. Similarly, in the second one, it is again starting where it left off. In the second dimension, it is going what? Red, green, red, green, red, green, red, green, red, and green. Okay. So this is how you can write 3 by 3 arrays in R. So this is better as compared to matrices, because you can store more information as compared to the matrices that is being employed in R. So moving on forward, now there is another popular data structure that is being employed in R that are referred to as factors. Now if you see here factors, it is like to make an R object, a vector is used to construct a factor. So what it means is that you will employ how to build a factor is that by using different vectors you can form a factor. So I'll tell you with the example what do I mean by this, how to use the data structure factor. So it keeps the vector and labels for each of the elements. So that is the defining feature of factors, that it uses it keeps the record of the vectors that are being stored, and it also stores something called levels. Okay, so they are referred to as their individual values, whether the elements in the input vector, it can be numbers, it can be characters, it can be boolean, it can be integers, it can be any other data types as long as you want. So the labels will always be character. Keep that in mind, that the labels that we are storing for factors will always be characters. Character means that it will be in the form of strings. So we can use, why we use this, because we have to use this for statistical modeling. That is why, because we have to use them for statistical modeling. So how to implement these factors in R? So it's a very simple function that is referred to as factor, and then we call and simple arguments that are being related to a factor command. So we have already seen that any data structure that you want to implement, what happens is that you take a particular data structure and write the name of the data structure followed by a round bracket. So in every other data structure you have already seen, like if you want to form an array, the array will be followed by a keyword array, and then the array keyword will be followed by something again round brackets. Similarly, this is true for every data structure. If you look in the previous PPT also, the data structures like lists, the data structures like vector, they are all using the keyword that is being in their data structure. Like if I want to use a data structure matrix, the matrix, it will directly start with the keyword matrix followed by what you want to put in the matrix. Similarly, the data structure array will be followed by directly whatever you use or whatever you put inside the array. Similarly for factors also, so if you want to do a factor, so factor will again directly be used whatever you want to factor. So factor, it's a little bit different than any other data structure. So the example that is being shown here is that They're telling you that the orange colors is a variable, and in that variable red, green, yellow, red, green is being stored. So actually there are only 3 values, but here it is shown as red, green, yellow, red, green, something like that. It is already being assigned to a variable called orange colors. Okay. So factor orange, what it will do is that you simply write factor, and in the argument part you give it orange colors. Okay. So when you give this to when you give it to orange colors, what will happen when you print the factor orange and print the number of levels? So what it will do, the print factor orange part will print all the colors that are being there. With it, it will also print the number of levels. So levels means how many there are unique values that are being there. So here only 3 unique values are there, like red, green and yellow. So it will with print orange, when you write the command print factor orange, with the color, with the number of colors, it will also store or also print the levels. So levels will be whatever are the unique values in that particular variable. So it will print that, and it will also, you can also print the number of levels by simply using n level command on factor orange variable. So this is again, so you already know there are 3 levels to this, so it can be used like that. So it is very similar to any other cases, like you can write male, female, male, female, male, female. So it can directly extract out that there are only 2 levels. Okay, so there are only 2 unique levels. So that is very useful in statistical modeling, that how many levels are there. So imagine here only 1, 2, 3, 4, 5, 6 colors are there, but imagine here like 1 lakh or 2 lakh colors are being, or 1 lakh or 2 lakh inputs are being given here. So it is very difficult for you to understand that which one of these values are unique. So for that you can simply write factor, and you, by using the number of levels or n levels command, you can get the unique values that are being deployed here. So that is the advantage of using factor variable. So the last data structure that is being deployed is referred to as data frames. So data frames data structure is very close to we call CSV files that you may have seen. So CSV files like comma separated file or Excel files, that you, everything that you store in the form of tables, anything that you store in the form of tables, can you can call it as a data frame. So data frames are tabular data items. Simply they are tabular data items. They just differ from matrices in that each column may include a variety of data items. So only difference is that with matrices is that each column may include a variety of data types. So different column can contain different data types, and each column can contain a variety of different data types. So you can put numbers in the first column, characters in the second, and logical in the third. So logical is another data type that you can enter in the third. So it is a set of identically sized vectors. So you can call it like they are a set of identically sized vectors. So again, it is very the syntax is very similar to what we have seen till now. So the syntax is data dot frames followed by round brackets. Function is used to build data frames. So it's very simple. We have already seen these kinds of syntax in the previous data structure. So this is also there. Now if you see in the example of it, so the example is that we have taken a variable BMI and we are trying to convert whatever is in there into a data frame. So BMI is a variable to which we are assigning data dot frame, and whatever is in there is in the round bracket. So if you see here, we are assigning first gender. Gender is male, male, female. So like we are building a table. Think of it like we are building a table, and first male have, if you want to add one or more column, you can also add a name here. Okay, so for your own practice, you take this code and you edit it, and you can add name, one column name also there. So it is writing gender first, male, male, female, and then the height first. Height is 152, then 171.5, and then 165, followed by weight, that is 81, 93, 78, followed by age 42, 38, and 26. So when you print BMI, that is being the variable that we have stored the data frame here. So what you do when you print it, it will be printed in the form of a table. You check in the output. So one more thing that is being added here are the numbers. Okay, so you can see here the numbers 1, 2, 3 is being added without a header, but this is just for the reference that how many entries that we have added. Then if you see here gender is, then you can see here gender is male, male, female. The height is 152.0, followed by 171.5, 165.0. Similarly, the weight 81, 93, 78, and followed by the age of the particular person. So if you want to edit that code, you can also add one more thing, that name of a particular person. So in that way the code will be complete. So you can add a name here just for your own sake of practice. You can add the names of male, male, and female. So you can add a names to it so that it can include one more column. So these are your data structures. Till now we have seen data structures that are lists, vectors, matrices, arrays, factors, and data frames. So most of the data structures you have already known about. The only few data structures that are new to this particular programming language are is the data structure factors. Another data structure is data frame. So a data frame means that you can write any data in the form of table. So like you are inputting a CSV file, so that is kind of a data frame. But if you want to create a table on the spot in the compiler or in the interpreter, you can directly use the data structure data frame. So factor is again, if there are many items listed, you want to identify the unique ones and you want to identify the levels. So that is very useful. So arrays, matrices are very similar to each other. The only differences is that so array can go up to 2 by 2, but the matrices, it's reverse. The matrices can go up to 2 by 2, but the arrays can go towards the dimension that is given by the user. So that is a definite advantage of using arrays. Another is that another data item is list and vector. So list is again a very popular data structure that is already being employed in Python, and it's again very similar to the implementation of Python with little bit of nuances that are being different. And vectors are again, you just simply use a C combine function to use any kind of a vector to form a vector. So these are the data structures, and we have covered 6 data structure in this particular session. In the next one we will start the data visualization using R. So thank you.